Imagine an envelope with a secret inside, a secret about the past. As long as it stays sealed, reality behaves one way. But if you open it, reality rewrites itself. This isn't science fiction. This is a real puzzle from the edge of quantum physics. An experiment so strange, it makes us ask if the future can decide the past. If you could change something that had already happened, would you? What if I told you there's an experiment in quantum physics that toys with that very idea? It's called the delayed choice quantum eraser, and it asks a question that sounds impossible. Can a decision you make now rewrite the past? We'll get to the actual science, the entangled photons, the beam splitters, the detectors, but before we drown in hardware and jargon, let's strip it to its essence. There's a way to picture this without needing a physics degree. It starts with something simple, something familiar, an envelope. Inside is the answer to a question about the past. Leave it sealed, and reality behaves one way. Tear it open, and the story changes. And once you've seen what's inside, you can't unsee it. Before we dive in, a quick note. If you already know the double slit experiment, you can jump ahead to the really mind-bending part, the timestamps on screen. But if you stay with me, you'll see why this humble experiment is the foundation for everything that follows. Because if you've ever wondered how a simple question like, which way did the particle go, could shake the pillars of physics, this is where it all begins. The setup is almost childlike. Fire particles like electrons or photons at a wall with two slits cut in it. Behind the slits is a screen that records where they land. If you close one slit, you get a clean band, just as you'd expect. If you close the other, you get a band in a different place. But when both slits are open, something miraculous happens. The particles don't just form two bands, they create an interference pattern, a barcode-like spread of bright and dark stripes, as if each particle is behaving like a wave, rippling out and interfering with itself. And the weirdest part? This still happens even if you fire one particle at a time. It's as though the particle somehow explores all possible paths before it hits the screen. But here's the twist. If you put a detector at the slits to find out which slit the particle actually went through, the pattern disappears. The interference vanishes. The wave-like ghost collapses. Suddenly, the particles behave like tiny bullets again. It's as if nature is saying, if you ask me which path I took, I'll give you a straight answer, but you'll lose the magic. So here's the mystery. Why does reality care whether we look or not? Does the act of measurement collapse the wave of possibilities? Does consciousness play a role, as some have speculated? Or is it simply that information, whether or not it exists in the physical system, is what decides? This is the stage where our story begins. But what makes it more than just a curious paradox is what happens when we push the question further. Because you might think, okay, the act of watching forces reality's hand, end of story. But what if you decide whether or not to erase that information after the particle has already hit the screen? What if the universe lets you change its mind retroactively? That's where the envelope metaphor comes in, and eventually where the delayed choice quantum eraser throws all common sense out the window. Think of it this way. Imagine that every time a particle passes through the slits, the universe writes down the answer, left slit or right slit, and seals it inside an envelope. The envelope is information. It holds the truth about the past. Now, as long as that envelope stays sealed, the particle's path remains a mystery. The interference pattern shows up on the screen because reality itself hasn't committed to a definite story. But if you open the envelope, if you learn which slit the particle went through, and the wave of possibilities collapses, the interference disappears. That's the essence of what the quantum eraser plays with, the tension between knowledge and ignorance, between what could be known and what is known. Here's where it gets even stranger, because you don't have to open the envelope right away. You can let it sit on your desk. Hours later, you decide to peek inside, as somehow the pattern that was already written on the screen has been retroactively decided. It's as if the universe was waiting for you to make up your mind before it wrote down its own history. Now, of course, this is a metaphor. No physicist is literally mailing photons in tiny envelopes, but it captures the unsettling logic of what's about to come. Because in the real delayed choice quantum eraser, scientists don't use paper and ink, they use entangled photons and detectors. And what they've discovered is that you can choose whether to preserve or erase that path information after the particle has already landed. You can decide whether the envelope gets opened or burned. And depending on that choice, the past seems to rewrite itself. Okay, time to swap envelopes for photons. In 1999, physicist Yoon-Ho Kim and his colleagues set up one of the strangest experiments ever performed, the delayed choice quantum eraser. Here's the setup. A laser fires photons at the double slit, but instead of hitting the screen directly, each photon is paired with a twin, a second photon created through a process called spontaneous parametric downconversion. In simple terms, one photon splits into two entangled photons, forever linked like cosmic twins. One photon, let's call it the signal photon, flies straight to a detector where it lands, making a little dot, just like in the regular double slit experiment. But the other photon, the idler, takes a more complicated journey. It's sent through a series of mirrors and beam splitters that either preserve its path information, which slit it came from, or scramble that information beyond recovery, effectively erasing it. And here's the kicker, those choices happen after the signal photon has already hit the detector. Think about that. The dot on the screen is already there, the past is already written, and only then do we decide whether its twin's envelope stays sealed, gets opened, or gets burned. Now, what happened? When researchers looked at the signal photons alone, just the dots on the screen, there was no interference. It was just noise, nothing spooky. But when they correlated the signal photons with their entangled twins, a hidden order emerged. If the idler photon's path was preserved, envelope opened, the signal showed no interference. If the idler photon's path was erased, envelope burned, the signal showed interference, as if it had gone through both slits. The pattern you see depends on whether or not the information still exists, and because the choice is delayed, it looks for all the world like the past has been rewritten. But here's the subtle point. Nothing travels backwards in time. You only see interference once you separate the data into subsets based on what happened to the idlers. Until then, the raw screen looks random. So no, you can't send messages to the past. You can't win the lottery by erasing envelopes. But the unsettling truth remains. The universe only decides whether a particle behaved like a wave or a particle once the question of path information is settled, and that decision can be pushed further and further downstream. If you thought it was weird so far, it's about to get weirder, because now we're going to ask an even crazier question. What if you only decide what to do with the envelope after the letter has already been delivered? That's exactly what the delayed choice quantum eraser tests. Remember, the signal photon has already landed on the detector, the dot is there, the past is written. But the idler photon, its twin, is still in limbo, racing through mirrors and beam splitters. And at the very last moment, the experimenters decide, do we preserve its path information, open the envelope, or do we scramble it beyond recovery, burn the envelope? And when you later compare the data, it's as if the signal photon somehow knew what choice you would make, even though that choice came after it hit the screen. This is where things get properly spooky, because it feels like the universe is reaching backwards in time to rewrite history. But physicists, being physicists, weren't satisfied with just one layer of madness, so they built a double eraser, a kind of cosmic Russian doll of envelopes. Here's how it works. The idler photon's path information can be preserved, but then with a second set of beam splitters and detectors, you can choose to erase it again. Imagine opening the envelope, reading the note, and then tossing it into the fire so no one can ever prove it was opened. And once more the universe plays along. The interference pattern reappears, as if the photon had always been a wave. The final decision, the ultimate fate of that envelope, can be pushed further and further downstream, and each time when the dust settles and the data is sorted, the past lines up with whatever choice was ultimately made. It doesn't matter whether the envelope was burned, sealed, opened, or burned again. What matters is what information survives. That's the mind-bending heart of delayed choice. To our human intuition, it looks like retrocausality, the future reaching back to edit the past. But to physics, it's subtler than that. Nothing actually travels backwards in time. Instead, reality refuses to commit until all the bookkeeping is done. Only when the envelopes are accounted for does the story of the photon finally make sense. Now, there's one man who took this whole envelope business far more seriously than just a teaching aid. His name is Tom Campbell, a physicist by training, but also a long-time consciousness researcher. He's the author of My Big Toe, toe meaning theory of everything, where he argues that physics, metaphysics, and even human experience can be unified under one framework. And Campbell's claim is as bold as it gets. Consciousness is fundamental. The universe itself is essentially a virtual reality, a kind of cosmic simulation. Not simulation in the Silicon Valley, we're all in the Matrix sense, but in the deeper sense that reality is rendered based on what information consciousness actually needs. Which brings us back to the envelope. In mainstream physics, whether the envelope is opened or not is just a matter of whether the information is available in the physical system. You don't need a person to open it. A Geiger counter, a detector, even a photon bouncing off dust is enough. Information stored means interference is gone. Information scrambled means interference is restored. But in Campbell's metaphor, the crucial step isn't the detector, it isn't the storage, it isn't even the act of burning the envelope. The crucial step is awareness itself. Until a conscious observer opens that envelope, the outcome isn't rendered. The universe, in his view, is literally waiting for someone to look. That's why Campbell points to the delayed choice quantum eraser and says, look, this is evidence that reality doesn't finalize until consciousness steps in. To him, the experiment is not just quirky physics, it's experimental support for the idea that consciousness creates reality. Now, mainstream physics doesn't buy this. Most physicists will tell you the eraser is weird, but there's no need to bring consciousness into the story. Measurement is just interaction, decoherence, information being available, no eyes required. But whether you agree with Campbell or not, his metaphor has power. It dramatizes the stakes of the quantum eraser in a way that sticks in your mind. Are we simply recording what reality always was, or are we, envelope in hand, editors of the past? Now, here's where the story stops being a lab curiosity and starts bending the entire universe into the equation. Light doesn't always travel in straight lines. Einstein showed us that gravity bends space itself, and with it the paths of photons. A massive galaxy sitting between us and a quasar can act like a giant lens, splitting the quasar's light into two possible routes that arc around either side of the galaxy before finally reaching Earth. In other words, the cosmos itself builds us a cosmic scale double slit. Here's the awesome part. Astronomers can set up their detectors in two different ways. They can look in such a way that they can tell which path the photon took around the galaxy. Or they can look in a way that erases that path information and instead produce an interference pattern, as if the photon went both ways at once across billions of light years. And just like in the lab, the choice of how we look seems to decide whether the photon's past was a single path or a superposition of both. Think about that for a second. A photon that left a quasar before human beings even existed may not have decided how it travelled until we observed it here, now. Our choice of measurement today reaches back across billions of years and rewrites what that photon did in the deep past. It doesn't mean time travel in the sci-fi sense. No one's grandfather is in danger. But it does mean something deeper, that the past isn't a fixed book written once and for all. It's a living manuscript, and the act of observation is the editor's pen. So what does all of this really mean? The delayed choice quantum eraser doesn't literally let you send signals backwards in time. You can't whisper to yesterday or rewrite history at will. But what it does is stranger in some ways. It tells us that the past itself is slippery, that what we call reality is bound up with information, choice, and observation in ways that don't fit our common sense. Think about it. A photon leaves its source billions of years ago, travels across the universe, bounces through our little experiment, and then, only now do we decide whether its past was a wave or a particle. To us, that looks like rewriting history. To physics, it's more like this: the past isn't fully real until the information about it is settled. That idea should make you pause, because it suggests the universe is not a fixed film reel, running from the Big Bang to heat death. It's more like a cosmic rendering engine, where frames of reality only sharpen into focus when and where they're needed. And if that's true, what else might still be open? Simulation theory says we may already be inside such a rendering engine, not metaphorically, but literally. If so, the quantum eraser isn't just an odd physics trick, it's a crack in the wall, a glitch in the code, hinting that the universe doesn't bother to render details until the player demands them. Or maybe it's even deeper. Maybe reality isn't simulated by aliens or future humans or supercomputers. Maybe reality is simulated by itself, a self-rendering system of pure information, a consciousness playing the only game there is, the game of existence. And that brings us back to Campbell's envelope. Whether or not you agree with him, the metaphor forces us to confront the strangest question of all. Are we discovering reality, or are we participating in its creation? If observation and information really do shape the past, then we are not passive passengers in a cold, indifferent cosmos. We are part of the mechanism that makes reality real, and that is terrifying and exhilarating. And maybe, just maybe, it's the universe's way of inviting us to open the envelope and see what's inside. So what do we do with all this? Maybe it means time is not a straight arrow, but a tangled weave, threads that only solidify once we tug on them. Maybe it means the universe is less like a book already written, and more like a story we're helping to tell. Because if the past isn't fixed until information is known, then the boundary between physics and consciousness isn't just blurry, it might not exist at all. This is where science and philosophy collide. The physicist says it's just math, probabilities, wave functions collapsing. But the philosopher can't help but ask, who's collapsing it? And why should reality care whether we look or not? And then there's the simulation angle. If our cosmos is a rendering engine, it makes sense that it wouldn't waste processing power on details that don't matter until we peak. A photon billions of years in flight doesn't need to decide its past until we demand the answer. That's efficient coding. But here's the wildest part. Even if we're not in a simulation, the effect is the same. Reality behaves as if it's being rendered, as if the universe itself is a mind, economizing, conserving, choosing. And if that's true, then maybe the envelope isn't just a metaphor, maybe it's the truth. Reality doesn't exist fully until it's observed, not because of magic, not because of mysticism, but because that's how reality is. So when you open your eyes in the morning, when you look up at the stars, when you ask questions about the past or the future, you're not just uncovering reality, you're helping to bring it into being. And that's both the strangest and the most hopeful implication of all. Because it means we are not powerless, we're not trapped in a cosmic machine grinding toward entropy. We are collaborators in the greatest act of creation there is, existence itself. So maybe the question isn't, what's in the envelope? Maybe the question is, what do you want reality to become when you open it? I really hope you enjoyed this deep dive into the quantum eraser experiment and its fascinating implications. Subscribe to Stellar Stories for more wonder, more science, more philosophy, more curiosity. See you next time.